to the Tennessee's at-home learning series for math. My name is Miss Williamson, and I am a 5th grade teacher in Tennessee schools. This lesson is the 13th in our series. I am so excited to be your teacher for this lesson. Welcome to my virtual classroom. If you didn't see the previous lessons, you can find them at the Tennessee Department of Education website, www.tn.edu/education. You can still tune into today's lesson if you'd like, but you may have more fun if you go back and watch our previous lessons first, as we'll be building on things we have talked about before. Today, we'll be learning about using the standard algorithm and place value strategies in order to multiply 3-digit by 2-digit numbers. Before we get started, to fully participate in today's lesson, you will need paper, pencil, and a surface to write on, or you can get the student packet for lesson 13 under 5th grade math at the Tennessee Department of Education website. I'll give you a moment to get your things gathered. Okay, let's begin. We are continuing to think about multiplying whole numbers. In the previous lesson, we learned about multiplying 2-digit numbers by 2-digit numbers. In today's lesson, we will build on the understanding to learn about using place value and the standard algorithm to multiply 3-digit numbers by 2-digit numbers. Let's start by looking at this problem. The local library collected 14 boxes of books for donation. Each box contained 163 books. How many books did they collect in all? Looking at this problem, what do you think that we need to do to be able to solve it? Well, how many books were in each box? 14. How many books were in each box? 163, and we have 14 what? 14 boxes. And so if we want to find out in all, what do we need to do? Yes, you're right. We can use multiplication to determine the total number of books that the library collected. Fabulous. So on your paper, can you write 163 times 14? Great work. We can use what we know about place value to break these factors apart and multiply. To better visualize this, let's use an area model. Can you draw a rectangle on your paper for me? Excellent. Now we're going to decompose our factors. What are the values of the digit in our first factor? Did you say 160 and 3? Great work. I know their values because where their place values are. What about our other factor? Can we decompose 14 into its value? Yes, we can break it up into 10 and 4. Great work. Now, what can we do inside of each of these boxes to find all our partial products? That's right, we can multiply 100 times 10, 10 times 60, 10 times 3, 4 times 100, 4 times 60, and 4 times 3. I'm going to give you a moment. See if you can find all the partial products inside of our area model. Excellent. Check your work. Did you get 1,630, 400, 240, and 12? What did you just find? That's right, you just found all the partial products for that question. Now, I'm hoping you're noticing some connection to multiplying by powers of 10. Do you see the multiples of 10? 100, 10, 10, 60 is a multiple of 10, 10. We have lots of multiples of 10 in our partial products here. So what do we do with our partial products to get our total? We add them. So let's do that. Let's line them up. 1,630, 1,630. We took care of our first 3. 400 plus 200 is 600, plus 40 is 640, and then plus the 12. 3 plus 4 is 7, plus 1 is 8. 6 plus 6 is 12. Regroup a 1. 2,282. So the library collected 2,282 books. That's a lot of books. As we work through the rest of the problems today, I want you to keep thinking about how these problems could be represented using an area model like the one we just used. Now let's use partial products to solve our next problem. Read this problem with me. Last month, the bakery sold 389 boxes of bagels. Each box contained 12 bagels. How many bagels did the bakery sell last month? Well, we could solve this problem by showing all the partial quotients or by using the standard algorithm. Let's use both and see how they are connected. But let's start by using partial products. Will you do this along with me? Are you ready? On your paper, write 389 times 12. Okay, and so first we're going to multiply the ones placed in 12 by all the digits on top. So let's start. 2 times 9 is 18. That's our first one. And then 2 times, what's the 8 worth? 80. 2 times 80 is how much? 160. Then what? 2 times 300. What's 2 times 300? 600. Great work. Now we have to move over to the tens place in 12. What digit is in the tens place of the 12? That's right, the 1. So the 1 is going to do the same thing the 2 did. It's going to visit every digit in 389. So 10 times 9 is 90. And 10 times 80 is what? 800. What about 10 times 300? What's 10 times 300? Did you say 3,000? Fabulous work. How many partial products did we end up with here? That's right, we found 6 partial products. How many did we find when we used our area model? We found 6 as well. I wonder if there's a connection there. We'll find out later. Now that we have all our partial products, we need to add them to find our total product. So can you do that with me? 8 plus 0 is 8. 9 plus 6 is 15, plus 1 is 16. Regroup a 1. 8 plus 6 is 14, plus 1 is 15, plus 1 is 16. And 3 plus 1 is 4. And so we ended up with 4,668 bagels that the bakery sold last month. Now we said we're going to solve this problem in 2 ways. We just used partial products. Now let's use the standard algorithm. So let's rewrite that problem. We're going to see if we can make any connections between the 2. Now I want you to jot in your paper, what is your prediction of how many partial products we're going to end up with when we use the standard algorithm? And we'll see if you're right. Jot that number down on your paper. All right, solve along with me and as we look for connections between the 2 methods. Just using the standard algorithm, we still start with the 2 or the ones place on our bottom factor. And we're still going to go to every factor on top, but we need to remember to regroup if necessary. Did we regroup when we used partial products? No, we didn't. But so when we do the standard algorithm, we have to remember to regroup if necessary. So 2 times 9 ones is 18, or 110 and 8 ones. So I'm going to put down the 8 in the ones place, and regroup the 110. Now 2 times 80 is 16 tens plus 1, 17 tens, or 170. So I'm going to put down the 70 and I'm going to regroup the 100. 2 times 300 is 600 plus 1 is 700. And so I'm going to bring down my 700. So our first partial product is 778. Fabulous work. Now here's a suggestion that I like to make. I like to mark these out, or if you're using pencil, erase them, because you don't want to get confused when you move on to the tens place. Are you ready? So now we need to go to the 1 in the tens place of the 12. 10 times 9 is 90. So I'm going to put 90. Did I regroup anything? No, I didn't. 10 times 80 is how much? 10 times 80 is 800. So I'm going to put an 8 in the hundredths place. 10 times 300 is 3,000. So I'm going to put a 3 in the thousandths place. Now we ended up with 2 partial products. Is that what your prediction was? Did you predict we were going to have 2 partial products? If you did, congratulations, you were correct. What do we need to do with our 2 partial products to get our final total? That's right, we need to add them. Let's do that. 8 plus 0 is 8. 7 plus 9 is 16. Regroup a 1. 8 plus 7 is 15. Plus 1 is 16. Regroup a 1. 3 plus 1 is 4. Are you noticing any connections between the 2 models? Great, I heard somebody say we had 6 partial products in this method, and I heard somebody say we only had 2 in this one. That's a great conclusion. What else do you notice? I heard somebody say if we added up all the ones in pink from the 2, we would get our first partial product on our standard algorithm. And if we added up all the ones in green from the tens place, we would get our second partial product in our standard algorithm. Those are great connections. Fabulous work. Now let's do the same problem using the area model. Can you draw a rectangle on your paper for me, please? Remember, when we use an area model, we decompose each digit based on its value. So the values of 389 are 380 and 9. It's like writing it in expanded form. And the values of 12, the values of the digit in 12 are 10 and 2. Great work. And so 300 times 10, 10 times 80, 9 times 10, 300 times 2, 80 times 2, and 9 times 2. Are you seeing any connections between these? Any other connections? Well, let's see if this helps. Do you notice that the top numbers match the numbers from the 10? And the bottom numbers match the value of our partial products from the 2? Excellent work. So now we can see how those are connected. Excellent job drawing conclusions. So we do notice that these 2 methods give us 6 partial products. And our standard algorithm only gives us how many? 2. Excellent work. We can also see that when I look at the partial products that have been decomposed from when we use partial products, I can add those up to get the partial product in the standard algorithm. So let's try some more problems together. Will you follow along with me on your paper as we think through 324 times 25? 324 times 25. Remember, we're going to start by multiplying each digit in 324 by the ones place from 25. What digit is in the ones place on 25? That's right, 5. But we also got to remember a very important rule, to regroup if needed. So I'm going to do a little bit of both. I'm going to do standard algorithm, but I'm going to write how I got those numbers over to the side. So let's do this first. 5 times 4 is 20. Do you agree? And so I'm going to put a 0 in the ones place, and I'm going to regroup a 2. 5 times 20 is 100, but I need to add how many tens? 2, so 120. So I only have 20 tens, and I need to regroup a 100. Then 5 times 300 is 1,500, but I need to add an extra 100 because I regrouped it to get 1,600. Now I'm going to go to the 2. The 2 in the tens place needs to visit all the digits in 324, just like we just did. But we have to remember that the 2 is not worth 2. What's the 2 worth? Yes, it's worth 20. So 20 times 4 is what? 80. So I'm going to put a 0 in the ones place and an 8 in the tens place. Now 20 times 20 is 400. So what's going to go in the hundreds place? Excellent work. 400. Now 20 times 300 is worth what? 6,000. So what's going in the thousands place? A 6. That second factor the second digit in that factor did not require us to regroup at all. Now remember, what do we do with our partial products? That's right, we add them. 0 plus 0 is 0. 8 plus 2 is 10, regroup a 1. 6 plus 4 is 10, plus 1 is 11, regroup a 1. 6, 7, 8. So our final answer is 8,100. Great work. Now, let's solve another problem together and follow along with me again on your paper. 624 times 31. What are we going to multiply each of the values in 624 by? Yes, we'll multiply them by the ones place in 31, which is 1. Let's do that now. Did you get 624? 4 times 1 is 4. 4 times 2 is, 1 times 4 is 4. 1 times 2 is 2. 1 times 6 is 6. Now we multiply each of the values in 624 by what? Yes, by 30. Why is it 30? Exactly, because a 3 is not worth 3, it's worth 30. So 30 times 4 is 120. So I'm going to put down the 20, and I'm going to regroup the 1. 330 times 20 is 600, plus 1 is 700. 30 times 600 is 1,800 or 18,000 or 1,800. That's wrong. It's 18,720. Now, what do we do with those numbers? That's right, we add them. 4 and 0 is 4, 2 and 2 is 4, 6 plus 7 That's right, 13. Regroup a 1. 8 plus 1, 9, and 1. And we get the final product of what? Exactly, 19,344. Now try solving the next multiplication problem on your own. After you've worked for about 2 minutes, we can come back together and check your work. Remember to write down your problem and to remember to start in the ones place of your bottom digit. The problem is 360 times 18. Remember, I'm going to give you about 2 minutes to do it independently. You have about 30 seconds left. Okay, let's check your work together. Are you ready? Remember, we start in the ones place. The ones place is going to go to every digit on top. 8 times 0 is 0. 8 times 60 is what? 8 times 60. What did you get? Did you get 480? So we put the 8 and we regroup the 4. 8 times 300 is 2,400, but we can't forget to add the 400 we regrouped to get 2,800. So for your first one, you should have gotten 2,880. Now we need to multiply by the tens place. Well, what do we know about anything times 1? That's right, anything times 1 has the same value. So 1 or 10 times 0 is 0. 10 times 60 is 600. 10 times 300 is 3,000. So now we have our partial products. How many did you get? You should have gotten 2. That's awesome. Now we need to add those. 0 plus 0 is 0. 8 plus 0 is 8. 8 plus 6 is 14. Regroup a 1. 3, 4, 5 plus 1 is 6. And so our end product is 6,480. You've done some great work. Students, I'm so very proud of your work today. We have reviewed using the standard algorithm to multiply 3-digit by 2-digit numbers. I hope you're seeing some connections to multiplying by a 2-digit number and multiplication. You sure did a phenomenal job. After the video, you will have some problems to practice on your own. Good luck, I know you will do your best. I will show you your independent practice problems now, or you can find them in the student practice section of the lessons posted on our website, www.tn.gov/education. I have so much enjoyed my time with you today reviewing the standard algorithm of multiplication, focusing on 3-digit by 2-digit numbers. Thank you so much for inviting me into your home, and I look forward to seeing you in the next lesson in the Tennessee at Home Learning Series. Bye, guys.
We know this year didn't go according to plan. Life occasionally springs a pop quiz on you, but you passed the test. Your family is proud of you, and Tennessee is proud of you. This year may have been different, but you met the moment and graduated. And we, at the Tennessee Department of Education, want to spend the next few weeks celebrating your accomplishment. Congratulations, class of 2020.
Hello, my most amazing, our list. Today, you're going to be creating with me. My name is Cassie Stevens, and I love creating. If you love making things as much as I do, you can find more videos just like this one on my YouTube channel. You can find me at Cassie Stevens. Today, we're going to be making something called origami. Origami is the Japanese art form of folding paper. Did you know that you can take a flat piece of paper and transform it just by folding it? Today, we're going to be transforming a piece of paper and creating a home. You could create your home, maybe a fantasy home, a beautiful home that one day you hope to live in. Speaking of home, when you're finished decorating it, you can share who is inside of your home. Maybe drawing your family, your pets, and more. All right, guys, let's get started. To create your origami house, begin with a vertical piece of paper. Take the top of the paper and bring it down to the bottom. Hold it in place and then fold in half. Now take the left side of your paper and bring it over to the right. Sometimes that can be tricky. Paper isn't always easy to fold. Be patient with it. Once you've got it folded in half, unfold, bring that left side to the center fold. There you go. This will be one side of our house. To create the roof, open that opening right there, bring it down and squish the triangle down. Same thing on the other side. Bring it over to the center fold, flatten it, open it, and bring down the roof. There you go. Can be a little tricky. A little practice can help you out. House is finished. Now let's decorate the outside of the house. It could look like your house. It could look like a friend's house or a family member's house. It could be a house of your dreams. The choice is yours. This is your masterpiece. So decorate it with a windows, some doors, flowers, plants, add a texture to the roof. You get to decide. Once the outside of your house is complete, what's waiting on the inside? Could you draw your family? Could you draw your house pets? Could you draw the furniture within your house? That's up to you. I'm going to focus on the people that I love that live in my house. I'll start with me. I'm just using some simple shapes and maybe even some other family members and my pets. Once you're all finished, then you can start to add color. You could use crayons, markers, and colored pencils. The choice is yours. Have fun creating.